Let me, next, I should share my screen. By the way, are the videos helpful?
Yeah.
Really? Okay, I think I have started recording. So let me open. I will do everything here so it can show in the record. If I go to the board, it will not show in the record. I'm trying to make things easier for you, even though I'm not supposed to. But I'm just trying to make things easier for you. You're supposed to pay me for that, right? Okay, guys. Capital Asset Pricing Model, CAPM. What is CAPM? Any ideas? Yes, but yes.
So the model is return from the assets from the investment.
Yes, you're correct. Actually, the name is self-explanatory. It is an asset pricing model, so it is used to price assets. As simple as that. What do we mean by pricing assets? To price assets is used to price assets. What does it mean? It simply means to value assets. It's an asset pricing model, so it is used to price assets, right? Okay, if you remember, actually what we are doing is regression, and we have seen simple regression. What's simple regression? Simple regression is a form of regression where there are just two variables, just one, of course, dependent and one independent. So simple regression is like this: y equals beta 0 plus beta 1 x plus u, right? We know y is dependent variable, x is independent variable, beta 0 is, what beta 0? Constant or intercept. What's u? Error term. And what's b1? b1 is the slope coefficient, right? It's easy for you to say slope coefficient, but what does slope coefficient mean? Actually, b1 is the coefficient of x, correct? But what is it telling us? It is telling us the degree to which x affects y, right? Because you know this is regression. Y depends on x, so it means x affects y. But how much does x affect y? We will know by this coefficient, right? And before interpreting these coefficients, we need to check statistical significance. I showed you, right? T-test. Yeah. Either you use T-statistic or you use probability value. Because this coefficient can be mathematically different from 0. We don't care. We need to find out if it is statistically different from 0. If it is statistically different from 0, it means it is significant, so we can interpret. If it is statistically equal to 0, it means it is insignificant. So even though here this B1 can be maybe 5, of course 5 is mathematically different from 0, 5 is not 0. But we need to check if this 5 is statistically different from 0. Statistic significance and mathematical significance are two different things. So if this 5 is statistically different from 0, which means it is statistically significant, we can interpret it means x has an effect on y. But if this 5 is statistically equal to 0, which means it is insignificant, then it means x has no effect on y. We cannot interpret, right? So that's the whole idea about simple regression we have seen. Now, I told you this simple regression can be applied in real life, and we saw an application some time ago. We saw optimal hedge ratio, right? How we can use it to calculate the optimal hedge ratio, like trying to hedge your position. So today we are going to see how it can also be applied in in the CAPM model. Actually, this CAPM model, like I told you, it's an asset pricing model. So it's trying to price assets, like find the value of assets. So this CAPM model follows the same logic of simple regression. So in this model, what we have is, I'll explain all these things. ROI equals, what should I put? I'll just put A plus B ROM plus U. Do you notice that this is a simple regression model? Is this simple regression?
Yeah.
It's regression model. ROI is dependent variable. ROM is independent variable. A is constant. B is slope. And this is error term. It's simple regression, right? But this model, I'm trying to get to somewhere. I will get there. So this ROI, what is ROI? ROI. ROI is the expected return of the assets, or let's say the stock. We mostly use it for stocks. Stocks are assets, right? Yes. This screen. Oh, messed up. Is it better? But I'm recording anyway. You can watch it. By the way, guys, if you don't understand what I'm doing here, you should watch this video 30 times. You will understand. If you still don't understand, watch it 5 more times. And if you still don't understand, you can send me a message on Teams. I will come and meet you where you are and explain, right? So this ROI is the expected return of the assets. I'm trying to define the terms. Of course, we know it is the dependent variable, right? This ROM is, what I'm trying to do is, I want to give you an overview of the CAPM before we can do the practicals. This ROM is the expected return of the market portfolio. The market portfolio. This A, or let's first of all see this B. B is, of course, we know B is the slope coefficient, right? But in the CAPM, it has a name. B is the beta. Beta. What's beta?
Equal to 1.
I'm coming. I'll get to there. But like, what is beta? What does beta mean? What is beta? Is a measure of risks.
The measurement of risk.
It measures the systematic risks, right?
Yeah.
So beta is a measure, or let me say beta shows the systematic risk of the asset, of the stock, whatever. Now the next thing is A. What's A? A is, of course, we know A is the constant, but in the CAPM, that constant has a name, alpha, but we call it Jensen's alpha. Jensen's alpha, right? Of course, we are not too much interested in U, is stochastic error term. U is the error term. So I'm just defining the terms, right? So this is simple regression, of course, and we have the expected return of the stock, the expected return of the market, and then we have the beta, which shows the systematic risks of the stock, error term, and then we have A, which is the Jensen's alpha. So what do you notice in this model? You notice that we are trying to predict, or we are trying to get the expected return of the stock by using the expected return of the market. We are trying to say the expected return of the stock depends on the expected return of the market times the systematic risks of the stock. Beta is systematic risks of the stock, right? So this CAPM, it has a lot of assumptions, which I don't like, many people don't like it. This CAPM assumes that there is an overall global portfolio, market portfolio, which contains every and any asset. So this market portfolio ROM contains all assets in the world, which is not possible. You cannot have such a portfolio. But that's what CAPM assumes. And it's saying that if you want to get the value of a stock, this value of the stock should depend on this market portfolio times the systematic risks of the stock. Now, since we cannot get this overall market portfolio because it is not observable, we use a proxy. So at times we use proxies like S&P 500, like other market indices. Actually, what we do is we use excess returns in the CAPM model. What is excess return? I will add one more thing here. ROF. ROF is the risk-free rate. I know those of you who are doing 503 with Kwan, which maybe you have seen some of these things, but I know you will see CAPM and market efficiency after the midterm. I know about that. ROF is the risk-free rate. I will incorporate it into this model, but let me explain what is the risk-free rate. If you know the risk-return trade-off, you know that the higher your risks, the higher your expected return, right? If your risk is low, your expected return should be low. If you want more risks, you should take, sorry, if you want more return, you should take more risks, right? That's a risk-return trade-off. But actually, there are some stocks, there are some assets which have zero risks. Like you invest in the asset, you are sure to get your return. So the return you get from these assets which have zero risks is known as a risk-free rate of return. But actually, in real life, you cannot really find an asset with zero risks. So we always assume that treasury bills are risk-free assets, especially US treasury bills. We always assume that they are risk-free, but it doesn't mean it is totally, because nothing is totally risk-free in life. So I'm going to subtract risk-free from both sides. So from this expected return of stock, I will subtract risk-free. And from expected return of the market, I will subtract risk-free. Why am I doing that? I'll explain. Why am I doing that? Is because I want to get excess returns. Excess. Now, risk-free rate of return is the return you earn if you don't take any risk, right? But the return is too small. You know, risk-return trade-off. If risk is low, return has to be low. So if you are not taking any risks, your return is too small. So investors generally want to take risks. So if you take some risks, you should earn a return which is higher than the risk-free rate of return. You understand? If you take no risk, then you should earn the risk-free rate. But if you take some risk, then your return should be higher than the risk-free rate because you need to be compensated for this extra risks. So that is your excess return. So actually, the expected return of the stock minus the risk-free rate of return gives you the excess return on that stock as a result of the extra risks you take, right? So this guy here, ROI minus ROF, is the excess return of the stock. And this guy, ROM minus ROF, is the excess return of the market. Actually, we also call it the market risk premium. It means the same thing. It's simply the excess return of the market. So this is the CAPM model. This is the complete CAPM model. So what is the CAPM model telling us? It is telling us that the excess return of the stock depends on the excess return of the market times the risks, systematic risks of the stock, right? That's basically what the CAPM is telling us. So now, you mentioned something that the beta of the market is 1. And I said I will get there. Let me explain that. I told you that this beta shows the systematic risks of the stock, not of the market. This beta here, this B here, is the systematic risks of the stock, right? But by definition, let me write something here. by definition, the beta of the market is 1. The systematic risk of the market is 1. Why is it 1? It is because CAPM is assuming that the market portfolio contains all assets. So there are some assets with high risks, there are some assets with low risks. Then when you find the average, it cancels out. So that's why the market beta is 1, right? So if the beta of the stock is higher than 1, it means the stock is riskier than the market. Correct? This B here is the beta of the stock, not of the market. But what we know in our mind is that the beta of the market is 1. So if this B here is greater than 1, it means the beta of the stock is higher than the beta of the market, which means the stock is riskier than the market. You should understand these things. If B is greater than 1, it means stock is riskier than market. If that B is less than 1, what does it mean? It means the stock is less riskier than the market. So it means the market is riskier than the stock, in other words. By the way, guys, are you understand what I'm doing? I feel like you are lost. It's fine? Okay. We will do all of this with Koan Hoja in 503, I can assure you, after the midterm. I love this course a lot, 503, so. Sorry? Of course. Yes, my screen is, I hope so. I hope so. It's been shared, right? Okay. At times I used to make a mistake. So guys, this is the CAPM model. I've defined what everything here is happening. So actually these are regression coefficients. Let me come back to this, our general regression. When we are doing regression, we are trying to find this beta one, right? And when we get this coefficient, it will help us to know how much X affects Y, right? It's the same thing in the CAPM. We are trying to do this regression and find B. And if we get this B, we'll check, is it greater than 1 or less than 1? If it is greater than 1, it means this stock is riskier than the market. If it is less than 1, it means the stock is less risky than the market. It's the same thing, right? Okay, in normal regression, this beta 0 is the constant, and I told you that at times the constant is not too important. We don't really care much about it because most of the times its interpretation is not logical. But in the CAPM, the constant is very, very important. This constant A, Jensen's alpha, is super important because actually this A tells us if the stock is fairly priced or it is mispriced. What do I mean by that? In an efficient market, this A should be 0. It should be 0, like if I put 0 here, what does it mean? It means it does not exist, right? So it means the excess return of the stock depends only on the excess return of the market and the beta of the stock. But if this A is not 0, if it is positive or negative, it means the excess return of the stock depends on this plus something else. So in that case, it means the stock is not fairly priced. It means the market is not efficient. The stock is mispriced. It is either undervalued or overvalued. If you can find any overvalued or undervalued stocks in the market, it means the market is not efficient, right? Because if the market is efficient, there are no undervalued stocks and there are no overvalued stocks. So I'm linking this to market efficiency. Market efficiency. I don't know how to spell this thing. Market efficiency. What is market efficiency telling us? Market efficiency is telling us that the stock price reflects all available public information. Whenever there is if there is any information which is out there, it is already reflected in the stock price, right? So as a result of that, we should have no undervalued or overvalued stocks. So I don't know how to write this thing. The stock price reflects all available public information. So there are no mispriced stocks. Mispriced stocks means overvalued. We don't have any overvalued or undervalued stocks. So there are no mispriced stocks. All the stocks are fairly priced. So this Genesis alpha is very important. If we run this regression and we find this alpha to be positive, it means there is an abnormal return. It means your return is not just dependent on this, but this A is also adding to the return. So it means you have an abnormal return. If we find this A to be negative, it means you are making less return than you should make if the market is efficient. But if A is positive, it means you are making more return than you should make. So there is an abnormal return. Do you understand? So this Jensen's alpha tells us the possibility of beating the market. Beating the market. If this A is positive, it means this stock has beaten the market. It has given a return which is higher than what it was supposed to be. So it has beaten the market. But if this A is 0, it means the stock is fairly priced. There is no undervalued stock, no overvalued stock, and the market is efficient. Right? Is everything understood? Okay. If everything is understood, I can now. Guys, by the way, if you see here, we're talking of returns, not prices. If you are trying to download the data, you will get prices. But we have to convert all these prices to returns. I can remember in one of the tutorial sessions, I showed you how to convert to return, right? So we need to get all of this. So to run this regression, what do we need? We need the return of the market. We need the return of the stock. We need a risk-free rate of return, which we will get from the return from treasury bills. And if we have return of stock, risk-free rate of return, and return of market, then we are done. We can run this regression. And if we run this regression, we will get our Jensen's alpha, which is a constant, and we'll get the slope coefficient, which is the beta of the stock, the systematic risks of the stock. And we have to interpret this alpha and this beta, right? So the alpha will tell us if the stock is fairly priced or it is mispriced. And the beta will tell us if the asset is riskier than the market or the market is riskier than the stock. Okay, if that is understood, I think on Microsoft Excel, what is that? Where's my data? I think this is it. Okay. So if you look at here, we have S&P 500. I told you that CAPM assumes that there is a global market which contains every stock. It's not possible. We cannot have a global market which contains every stock in the world. So we always use a proxy for the market. So we use a market index. So one of the market indices we often like to use is S&P 500. It contains the top 500, I think, largest stocks in the US, something like that. Yes. You want to say something? So this S&P 500 represents the market portfolio. Then this Ford is a company. So this Ford is a stock, like a company. And then these US Treasury bills show us the risk-free rate of return. I told you risk-free rate of return is a return you get if you take no risk. But in real life, there's nothing which has no risk. So we always assume that Treasury bills, the return from Treasury bills are risk-free, because especially US Treasury bills, because if you invest in US Treasury bills, you are sure to get your money back. So it's not like there is any risk of default or something. So we always take treasury bills, actually T-bills to be, the return from T-bills to be the risk-free return. So what I want to do is, I want to run this regression. Where was I writing? I want to run this regression. Return of stock, I'll get it from, this is a stock. This fourth series is a stock. So actually we have prices, we'll convert all these prices to returns. So I'll get a return of the stock from this fourth. Now what next do I need? I need return of the market, which I'll get from S&P 500. It's a proxy for the market. And then the next thing I need is risk-free rate of return, which I'll get from T-bills, right? Treasury bills. And then I'm done. Okay, so I'm going to eViews. To my eViews. I want to create a work file. You know all these things, right? So let me look at the data. How is the data? Actually, this is monthly data. You see January, February, March, April. So it is January 2002 right up till, let me check, January 2002 till April 2013. So on eViews, I'll change from annual to monthly. And start date, all that right?
January 2002.
January 2002? January. Yes. No, wait, say something. I want to show what you're writing. What should I write?
You need, no, we can write just 2002.
If you remember, when I showed you how to use monthly data, did I show it? You didn't watch the video?
I did.
So actually, you write the year, and then you write the month. What's M01? January. If it's M04, what does it mean? Like April. So M01, 2002, sorry. What was the end date? Let me check.
2013.
2013, April, right?
Yeah.
Okay. So here I'll write 2013. April is fourth month.
You can write the actual date as well.
Sorry?
You can write the actual date as well.
Of course you can do that, but you might face some difficulties.
What I do is like I write 2010 slash.
Well, it doesn't matter. Whatever you write, it will still come out, but it depends on you. But you should just take it this way. M01 is like the first month, and M04 is like April, fourth month. So if I do that, now I want to have my data. What is my data? Let me check. Our data is S&P 500 fourth treasury bills, right? So I'll write, you can use anything here. So I'll just write SP 500 for S&P 500. I'll write fourth, and I'll write T bills. You can use any, you can represent it anyhow. So now I have my work file. The next thing I should do is, what is the next step? Copy paste. So I have S&P 500 for treasury bills. Just copy just the data. Actually, there's another way you can import this data to eViews, which I've not shown you. There's nothing important. If you know how to copy paste, you don't need to know. So I just copy paste on eViews. Paste in the first cell. So I've brought in my data to eViews. I can now close this guy. So you see here is fourth. This is the stock. This is S&P 500, the market prices, and treasury bills, right? Okay, now I don't want the prices. These are all prices. I want the returns. Because if you look at the CAPM, I told you that ROI is expected return of the asset. ROM is expected return of market. So we want returns, we don't want prices. So I have to convert all these prices to returns. How do I do it? I said it. Generate, yes.
For example, for Ford, we like rename then R4.
Okay, so let's do it first for S&P 500. So I can call the return of S&P 500 maybe ARU SP 500. I can add ARU behind to mean return, right? You can name it anyhow you want. So I want to generate a series called ARU SP 500. And what's the formula?
100 times
100 times D log
of the parenthesis. And then what is
SP 500. Fine, right? What am I saying? I'm telling e-views to generate is the return of S&P 500 by using this formula. So I'm telling e-views that they should take the logarithm of this series, then later they should take the difference of the log and then multiply it by 100 because I want it in percentage. So once you input that command, e-views understands, and if you press enter, you get it. So you see this is the return series. This is the return for S&P 500. You can do same for Ford and T-bills. So generate ARU Ford, return of Ford equal 100 times D log Ford. Guys, actually there are many formulas to get returns. This is not the only formula.
That's not quick.
I know like 4 different formulas. Should I show you all, or you like this? Maybe if I show you, it might confuse you. So let's just leave it at this. But there are other formulas. We'll get to the same answer anyway. So generate ARU Ford equals 100 times D log. I hope I've made no mistake. Ford, right? So let's do T-bills. Generate ARU T-bills equals 100 times D log T bills. It's fine, right? No, I've made no mistake, right? Let's check because is it fine? Okay. So I have generated the return series, right? So if I go back to my CAPM, what do I have? I have return of stock, which is Ford. I have return of market, which is S&P 500. And I have the risk-free rate of return, which is T-bills, right? But now I want to get the excess returns. Remember, I told you we are calculating excess returns. So to get the excess return of the stock, simply take the expected return of the stock minus the risk-free rate of return. Understood? But there is a problem. This risk-free rate of return, where is it? If you look at these are monthly figures for S&P 500 and Ford, monthly data. But this risk-free rate of return are annualized values. Like we have gotten the return from treasury bills. They are annualized. That is, it is like annual figures. So we should convert these figures to monthly figures. What should we do?
Divide them?
Divide by 12.
Yeah.
There are 12 months in a year, right? Are there 12 months in a year? Are there 12 months in a year? How many months do we have in a year?
12, I say.
12, right? But it's like in some countries they have 13 months. I heard there's a country where they have 13 months. I don't know. I'll check. So we should divide these guys by 12. So I'll go to e-views. I want to generate something. What should I write here? That is return of T-bills. I want to divide it by 12 so that I should get it for monthly because it's annualized figures. So I can write generate, it will be too long. Months, I don't know. You can abbreviate monthly return of T-bills equals to return of T-bills divided by 12. So you see, this is monthly return of T-bills. So this, yes, question?
Excel.
Excel.
I mean, isn't the first one January, the first month of 2002, 1.73, and February, the second month, the prices changed. How I'm confused. Like in each month, the treasury bills prices are changing. So why it's annually, not monthly?
These figures are annualized. Have you done 503 investment? Yes, I see. Those who are doing investment, have you done annualization? You should. That's one of the first things. Have you done it?
No, but I'm just like, the data is not the data.
Yes, it is monthly data, but it has been annualized.
How come?
How come? How can I explain this? Annualization. Investopedia. What is annualization? To annualize means to convert. What's happening? Read this statement. To annualize a number means to convert a short-term calculation or rate into an annual rate. So it means you can have this rate as a monthly rate, but you can convert it to an annual rate, but you still have it in monthly frequency.
So in this case, we should multiply them by 12.
No. Wait, let me explain to you something. Let me open Excel. Let's say we have January, February, March, April, whatever. So let's say we are trying to get observations. So let's say in January, we have a figure of $2. In February, we have $5. In March, we have maybe $9. What's happening? April, we have maybe $7. So these are our monthly observations, right? But you can annualize these figures. So this, in January, this is the figure, but you can annualize it and get a different figure. Down to February, this figure, you can annualize it and get a different figure. You come to March, this is the figure for that month, but you can annualize it and get a different figure. So you discover that you will still have figures every month, but now these figures here are annualized figures. Do you understand? Let me, I think you should do this thing in 503, except maybe they changed. Let me check my 503 slides. I think this is we did this thing before the midterm. Okay, now 503 investments. 1 minute, please. I think the first chapter was, this is the first chapter. Yes, let me just check 1 minute, please. Why is not downloading? Is this the first chapter you did? 503? Okay. Weeks are written, right? It's quite long. 73. Holding period return, blah, blah, blah. Have you seen analyzing? This is, I think we did this beginning of semester. To annualize means like, why will you annualize returns? So go back and read it. So you are trying to look at it from the perspective of a year annually, because you can have returns in monthly figures or maybe biannual, that is every 6 months or whatever. But in order to compare returns, you try to look at them from an annual perspective. So you annualize them. So there is a way you can annualize it. This is an example in the slides. Those who are taking this 503 course, you can read the slides. There's a way you can annualize it by compounding, by discounting, all those kind of things. Yes.
But here the HPO or in years.
No.
Yeah, here's the question in the example. Holding it for 2 years.
Which example?
The example, that one. Here, this one. He's holding it for 2 years. He's calculating the HPR. So to annualize.
You are holding it for 2 years.
Exactly.
Then you should annualize it for 1 year. You should bring it to 1 year.
Okay, but
You have not taken the course, so you face something. Are you doing 503? Are you taking 503? If you have it for less than a year, you can take it up to 1 year. If you have it for more than a year, you can bring it down to 1 year. So with one you compound and the other one you discount. So there is a way of doing it. Sorry? Of course, if you are discounting, it means you are looking for present value. If you are compounding, you are looking for future value. So then you will take the course. So you look at it. Okay, that was just an aside anyway. So if you notice, where am I? This, these treasury bills, I just copied this data and put on Excel because I want to use it. But treasury bills, these figures are annualized figures, right? But if you discover that these S&P 500 figures are monthly figures, these fourth figures are monthly figures. So if you want to compare them, we should compare them on the same basis. You cannot be using annualized figures and you're trying to compare with figures which are not annualized. So we should remove the annualization from these treasury bills by dividing by 12 so that we can compare everything on a level platform. You understand? If these S&P 500 and fourth figures were also annualized, then we'll just use these treasury figures directly. But since they are not annualized, that's the reason why I'm dividing these T-bills by 12 to remove the annualization. Yeah. Sorry? Yeah, it's because you are seeing the data on my Excel. That's why you are seeing that it is monthly. But if you go and see the data where I got the data from, you will discover that it is annualized data. I just put this data on Excel. It's not like this is the data that I got. I just put it on Excel, but it is annualized data. You get the point? So on e-views, I've done that. I have divided by 12. I have taken out the annualization. So I have the monthly. So what should we do next? I'm going back to my CAPM. So we discover that the next thing to do is to get the excess return, right? How can we get excess return of stock?
anything for the formula, the equation of the monthly analyzed treasury bills?
Sorry?
E-bills.
E-view? You have to
see-
copy something.
Yeah.
But you can watch the video.
Okay, so you analyze the returns of the treasury bills.
Yes, because I'm not annualizing it. The returns of the treasury bills are annualized.
Okay.
So I want to remove the annualization by dividing it by 12, because annualized means like it's looked from the perspective of annual, a year, and there are 12 months in a year. So divide by 12, you remove that annualization. So we can compare everything on a level platform. Understood?
Exactly. So if it was given to us monthly anyway, from the initial data, we would not have that.
Yes, yes. If you were told that it is not annualized, but I doubt. They will just tell you treasury bills. Nobody will tell you that it's annualized, but you should know that generally, typically, they are always annualized. So you should divide by 12 unless the question specifies otherwise. It's fine?
Yeah.
Any problem?
No.
Okay. So after we have done that, what are we to do next? We should get excess returns, right?
Yeah.
We should take return of stock minus return of minus ROF. Actually, guys, to make your life easy, you can do this on Excel, and then you just bring the final figure to eViews. Like, let me show you something. Like on Excel, if I want to get monthly T bills, what can I do? I can just put a formula. I say this divided by 12, right? Then I just double click here and everything goes down. So now I will just copy this data and take to eViews. So it's not like you must do it on eViews. You can do it on Excel and then you just take the final data to eViews and you use.
But you still need to calculate the returns of that, right?
Yes, and you can still calculate returns on Excel. Do you not calculate returns on Excel? Should I show you? Like for instance, I want to calculate returns of Ford. Let me show you. Actually, we are going to use returns on Ford will be actually we have discrete returns and we have log returns.
Yeah.
Which one should we use? I think on Excel we are using log returns. Let me see. Excel we are using log anyway, guys. Forget about it. It's not complicated. Do it on eViews. Okay, so for monthly, to remove the annualization, you see you can do it on Excel. Now you can also calculate the excess returns on Excel. I think it's easier that way. So for instance, excess, what should I do right? Let me put here, excess returns. So excess returns for Ford. So I'll put, oh my God, surprise, these are not returns, no use there. What can I do? Okay, let's do it on eViews. Guys, to get the excess return, just take the return series minus the risk-free rate. Understood? Let me show you. To get the excess return of the stock, just take the return of the stock minus the risk-free rate of return. And to get the excess return of the market, just take the return of the market minus the risk-free rate of return, right? So I'm going to eViews to do it. So what I'll do is generate. You can do on Excel, but let's do here. Generate. What's the return of stock? What did we called it? Ford, return of Ford. So I want to generate excess return of Ford. So I can put Ford, excess return Ford. You can call it anyhow. Ford, which is equals to, what's the formula? It will be return of Ford minus what?
The monthly.
Minus monthly. Monthly return T bills. And I press enter. Understood? Look at the formula again. Excess return of stock is return of stock minus risk-free rate of return, right? On eViews, it is return of stock minus risk-free rate of return. Fine. Then we are using the one where we have removed the annualization. So I should also get excess return of market. Look at the formula. What's excess return of market? It is the return, expected return of the market minus the risk-free rate of return, right? So on eViews, I should generate expected, what was the market? it was return S&P 500. So expected return SP 500 should be equals to return SP 500 minus monthly something, monthly return T-bills. Understood?
Now we're going to
So now you see I have gotten my excess return of what? And excess return of market, right? Okay, guys, look at, once I've gotten excess return of stock, it is actually our Y. Excess return of market is our X. So I can run the regression, right? And we have a constant, we should include a constant in the regression because we want to get the value of Jensen's alpha. So dependent variable is excess return of stock. Independent variable is excess return of market, right? So how do we run the regression?
LS excess return of 4. LS this square.
Yes, is that what you use?
Yeah, that's how what I use.
Okay, but I showed you a quick method.
It is confusing a little bit.
Instead, it makes your life easy. That's why it is quick. Can't you see here quick?
Okay.
If you tell you that it is quick, then it means it is quick.
I don't trust it. I have trust issues.
If you told you it is quick and you said it's not quick,
I mean, what's the problem with LS? It's just
there is no problem. But I like to be quick.
okay, you're gonna click quick, and then you're gonna find for the generate or descriptive or
No,
regression.
if I click quick,
Okay.
I just come to estimate equation,
Equation.
and that's all.
Okay.
I don't need to type ls blah blah blah. This is the ls here. It is already here. So the only thing I do here is I just put my variables. Just put dependent variable, put constant, put independent variable, and press OK. It's quick. If you said it's quick, but you said it's not quick. So what's dependent variable?
Expected return of 4.
Expected return 4. You give a space. You put C for the constant. You give a space, and then you put independent variable. Expected return SP 500. And you just press enter. Okay, you get regression results. Quite easy, right? This is our regression results, guys. Actually, how do we interpret these results, guys? 1 minute, let me check something. I hope I did not make any mistake with all this formula here. I'm just checking to be sure. Expected return of 4 is return of 4 minus T-bills, yes. Expected return of S&P 500 is return SP 500 minus monthly T-bills. And what is monthly T-bills? It is return of T-bills divided by 12. Return T-bills is okay. Okay, guys. This is our regression results. How do we interpret it? How do we interpret our? How do we interpret these results, guys?
When we say for the one increase, is it like 1% increase of expected return of SP 500?
Sorry.
The unit. If 1% increase here, we're gonna say
By the way, let's write our equation. Let's write the equation. So this is our equation. Let me copy it and bring down here. So what's the value of beta?
It's plus 1.532390.
It is 1.53, let's say 1.53, whatever. 1.53. So I'll put here 1.53, right?
Yeah.
What is
Alpha is negative 0.43.
alpha is negative 0.43, okay. So I'll put, where am I got? I'll put here negative 0.43. So I should remove this error term, right? Okay, this is our regression model. So how should we interpret our regression results? Yes,
1%?
yes, you can say, you can interpret it the way we always interpret it. But before interpreting these results, we need to check statistical significance. These coefficients, are they significant or not? You cannot interpret coefficients which are not significant, right? So we should look at the significance of these coefficients. So you can use t-statistic, you can use probability value, but either way you get the same answer. With t-statistic, what do we do?
It's the role of just
If the yes,
2 or more.
yes, if the t-statistic in absolute value is greater than 2, we should reject the null. What's the null hypothesis? The null hypothesis says that the coefficient is equals to statistically equals to 0. That is insignificant. So, by the way, I've done all of this. You should go back and watch previous videos. So if this, so we will see our t-statistics here is greater than 2, which means this coefficient is significant, right? So we can interpret. You can also check probability value. It is less than 5%, less than 1%, less than 10%, whatever. So it means in all those levels of significance, we can reject the null and accept the alternative that it is statistically different from 0. If you look at this constant, is it significant? No, because this guy is less than 2, right? And if you check even the probability value, it is bigger than 10%. So this guy is not significant. So what does that tell us? It tells us that this guy, this constant, Jensen's alpha, is insignificant, right? Why this beta coefficient is significant, right? So what does it mean? Okay, before doing the interpretation, what did I tell you? I told you that this Jensen's alpha, this constant, is very important. It tells us if the stock is fairly priced or if it is mispriced. If this guy, this constant, is statistically equals to 0, that is, if it is significant, then it means the stock is mispriced, right? It means because this Jensen's alpha should be 0, it should be statistically equal to 0, it should not be significant. Because if this constant is significant, it means the stock is not fairly priced. If it is significant and positive, it means there is an abnormal return. It means you are earning a return which is higher than what you are supposed to earn. If it is significant and negative, it means you are earning a return which is lower than what you are supposed to earn. So you see, actually it is negative. If it would have been significant, then we would have said you are earning a return which is lower than your actual return. But unfortunately, it is not significant. So it means statistically it is equal to 0. So it means this stock is fairly priced. That is it for the alpha. Now for the beta, systematic risks of the stock, it is greater than 1, right? I told you that by default, where did I write it? By definition, the beta of the market is 1, right? So if this beta here is greater than 1, it means the stock is riskier than the market. But if this beta is less than 1, it means the stock is less risky than the market. But of course, we see 1.53 is greater than 1, right? It is mathematically different from 1. But we need to check if it is statistically different from 1. So if you look at on E-views, this T statistic and this probability values here is testing the null hypothesis that it is equal to 0. Let me write the null hypothesis. I've done all of these things. H0, what's H0? Beta equals 0. What's H1? Beta, I don't know how to write not equal. Not equal 0. So this is the normal, null, and alternative hypothesis we have that we know. And this is what these results are testing. This T statistic and these probability values are testing this null hypothesis. But for this beta coefficient, we want to test a different null hypothesis. We want to test if it is actually different from 1, equals to 1, or different from 1. So we are not testing whether it is 0 or not. We are testing if it is 1 or different from 1. Why? Because by default, the market beta is 1. So we want to know if this number is statistically different from 1 or not. If it is statistically different from 1 and it is greater than 1, it means the stock is riskier than market. If it is statistically different from 1 and it is less than 1, it means market is riskier than stock, right? So we should change this hypothesis. How do we change this hypothesis on E-views? We should use word tests. So come to view, come to coefficient diagnostics, come to word tests, and then you put a restriction here. Why am I putting a restriction? Look at this model. This is the first coefficient, right? The constant is the first coefficient in the model, and the beta is the second coefficient, so it is coefficient 2. So I want to put a restriction. What is the restriction? I want to restrict that this coefficient 2 should be equals to 1. I want to test that hypothesis. So I will use coefficient 2. So my restriction here, I will put C equal 1. It's even written down here. There are some examples down here you can see. So if I write here C2 equals 1, it means I want to test the null hypothesis that it is equals to 1, because the normal hypothesis we test with the regression is it is equals to 0. But for this special case of beta, I'm interested in knowing if this beta is equals to 1 or it is different from 1. Why? Because if it is statistically equal to 1, it means the stock and the market have the same risk. But if it is statistically different from 1, it means the stock and the market have different risks. If it is statistically different from 1 and greater than 1, it means stock is riskier than market. If it is statistically different from 1 and less than 1, it means stock is less risky than market. By the way, is it understood? Do you understand? Okay. So once I put this restriction and I press OK, I have my results. So I'm interested in checking the probability values. You can look at all these probability values, T statistic or F statistic or chi-square statistic. Most of the time they give the same results. So if you look at these probability values, you discover that 0.01, they are less than 5%, right? Less than 5%, right? So since probability value is less than 5%, it means at 5% level of significance, we can reject this null. We can reject the null hypothesis. So we are rejecting the fact that this coefficient is not statistically equals to 1, and we are accepting the alternative hypothesis that it is statistically different from 1, right? If it is statistically different from 1, it therefore means that this stock has a different systematic risk from market. If it was statistically equals to 1, then we would have said this stock, the systematic risk of this stock is equal to the systematic risk of the market. But since we have seen that it is statistically different from 1, it means the systematic risk of the stock is different from that of the market. So now we need to check, is it riskier or less risky? Of course, 1.53 is greater than 1. What does it mean? It means that the systematic risk of this stock is higher than the systematic risk of the market. Understood? Is it fine? I feel like you are not understanding what I'm doing here. If you have any questions, you can ask.
Can you go to review and show, like from view, can you show us the steps again, please?
I'm recording.
I just want to read them. I'm typing down.
Why are you writing when you can watch the video? Sorry? You don't want to watch the video? Really?
Instead of laughing, it's not funny.
Really? You don't want to watch the you don't want to watch the video? For real?
You don't just sit all day long at home. You have things to do. So if you
What are you doing? You should not have things to do. You should study all your life. Why do you spend time doing other things? So you want me to run the regression again? And
No, just the last one. That view to find the coefficient of beta one.
but I deleted the regression, so I have to anyway. Let's do it. Quick estimate. What was dependent variable? Excess return for constant. Excess return SP 500. We have our coefficients. Of course, these t statistics and these probability values, they test the hypothesis that it is equals to 0, right? So we are going to test this hypothesis for the alpha, because it is important for this alpha to be statistically different from 0. Why? Because if this alpha is not statistically different from 0, if this alpha is statistically significant, which means it is statistically different from 0, then it means the stock is not fairly priced, right? It means the stock is mispriced. Now we need to know if it is overvalued or undervalued. If this alpha is, the first thing you should check is if this alpha is statistically equals to 0 or not, if it is significant or not. That's the first thing to check. If it is statistically equal to 0, which means it is insignificant, then it means the stock is fairly priced. We don't care again whether this value is bigger than 0 or less than 0 mathematically. But if you test the hypothesis and you discover that this alpha is statistically different from 0, which means it is statistically significant, then it means the stock is mispriced, which means there is either an undervaluation or overvaluation. In that case, now we need to check the mathematical value of this guy. If it is positive, it means there is abnormal return, which means the stock is undervalued. Undervalued. If alpha is positive, undervalued. Confusing, right? I'll explain. But if alpha is negative, it means the stock is overvalued. Why are you looking so surprising?
Can you repeat that one?
It's confusing, but it's fine. I like things which confuse people.
Okay.
Guys, let me explain something to you.
Can you just before the HP, the hypothesis testing, instead of beta 0, can you do it for
If
beta 1?
I will do it, I'm still with alpha, Jensen's alpha. This CAPM model, one thing I like this CAPM model is that it's showing us two things. This alpha is showing us market efficiency, and this beta is showing us the systematic risk of the stock. Is the stock riskier than the market, or is the market riskier than the stock? So there are two things we are getting from this CAPM model. Now, with this Jensen's alpha, we are testing the normal hypothesis we know. Coefficient is equal to 0, coefficient is different from 0. We want this alpha to be insignificant, that it should be statistically different from 0. Why? Because in an efficient market, if efficient market hypothesis is working, then it means there is no alpha. It means you cannot beat the market, because if you have positive alpha here, then it means you are beating the market. You have abnormal returns. If you have negative alpha, it means you are earning less than what you should earn. So it means the market has beaten you. Let me put it that way. So in order that you should not beat the market and the market should not beat you, this alpha should be statistically equal to 0. It should be insignificant. So to test for this alpha, we are using this hypothesis, equal to 0, not equal to 0. Now, the first thing is we should check if this alpha is significant. If it is insignificant, then we don't even check the mathematical value. We just conclude that there is no alpha. Therefore, this stock is fairly priced. It is not mispriced. The market is efficient. But if this alpha is significant, that is, it is statistically different from 0, it means the market is not efficient because we have alpha, right? So it means there is either an undervaluation or an overvaluation. But then how do we check if it is undervalued or overvalued? We then check the mathematical value of the alpha. If the alpha is positive, after we have decided that it is significant, if it is positive, so let me put here 5, let's assume that 5, positive value, it means there is an undervaluation. The stock is undervalued. Why? Why is it undervalued? Because this guy, that is the CAPM valuation. That is what CAPM is trying to do, to value these assets. But the CAPM model is telling us that this CAPM valuation is less than the actual price of the stock, because the actual price of the stock includes this extra guy. So it means CAPM has undervalued the assets. Do you understand? So when this alpha is positive and significant, it means the stock is undervalued, correct? If this alpha is negative, let me put here negative, it means the stock is overvalued. Why? Because CAPM has said that this is the price of the stock, but actually the price of the stock is this guy minus 5. So the price is less than what CAPM has given you. So it means CAPM has overpriced the stock. So if alpha is negative, it means we have an overvaluation. The stock is overpriced. But if alpha is positive, it means the stock is undervalued. Understood? Okay. So that is it for alpha. But now for beta, we are not going to test whether it is 0 or different from 0. We are instead testing if it is 1 or different from 1. Why are we doing that? It's because by default, the systematic risk of the market is 1. If the systematic risk of the stock is greater than 1, it means the stock is riskier than the market. If the systematic risk of the stock is less than 1, it means the stock is less riskier than the market. So we want to first of all check if this value, of course, mathematically 1.53 is different from 1, but we want to check if it is statistically different from 1. So we should test this hypothesis. If it is statistically insignificant, which means it is not statistically different from 1, then we don't even need to check this mathematical value. We just conclude that the systematic risk of the stock is equal to the systematic risk of the market. But if it is statistically significant, which means statistically different from 1, then now we need to check this value. Is it greater than 1 or less than 1? If it is greater than 1 and significant, it means the stock is riskier than the market. But if it is significant and less than 1, it means the stock is less risky than the market. That is, market is riskier than stock. Do you understand? So how do we test this hypothesis of equals to 1 or less than 1? The normal hypothesis we have on e-views, that is by default when you run your regression and you're using t-statistic and probability value to check the hypothesis, it is the hypothesis of equal to 0 different from 0. So for this special case of beta, we want to use by the hypothesis equals to 1 different from 1. So we should do word test because we want to put a restriction. Now, in this our estimated, what was this value, by the way? It's negative 0.43, right? Negative 0.43. You can't see, but if you watch the video, you'll see. I want you to watch the video. Why don't you watch the video? It's really, I'm shocked because I know how I gained a lot from watching videos. Like when I was doing my master's, most of it was during COVID semester, so everything was online. And most of the lecture, except Koan Hoja, of course, Koan Hoja makes things difficult for people. All the lecturers will record the videos. They will teach and record, so you can watch it later. It makes your life easy. Because you know, at times in class, the lecturer can be fast. He can say so many things, you cannot write everything. But if you go back and watch the video, you can be pausing it and watching it gradually. You can listen to everything and you get maximum benefit. So I'm surprised you don't watch the video. Okay, guys. So we want to check if this guy is statistically different from 1 or not. So we want to change the hypothesis. On eViews, come to view, coefficient diagnostics, word tests, and then here we should put a restriction. How do you know what restriction to put? If you check back here, our estimated equation, you see this is the first coefficient. The constant is always the first coefficient. It's a coefficient. And our beta here is the second coefficient, right? So we'll use C2, like the second coefficient. If it was the first coefficient, we'll use C1. C stands for coefficient. So we are interested in this beta, which is the second coefficient, and we want to put a restriction for it to be 1 because we want to test the hypothesis equal to 1, different from 1. So here I should just put C1, sorry, C2, it should be C2, right? Because the second coefficient equals to 1. And if you press enter, you get the results. So these are the results. Just check these probability values. You discover that all these probability values are less than 5%. This is 0.01. It's greater than 1, yes, but it's less than 5. We use 5%, 95% significance level. Less than 5, right? What does it mean? It means at 5% level of significance, reject this null hypothesis. If the probability value is less than the significance level, you should reject. If the t statistic is greater than 2, you should reject. So for t statistic, in order for you to reject, it should be greater. For probability value, in order for you to reject, it should be less than. Don't get confused. So these probability values are less than 5%, right? So we should reject this hypothesis. So we are rejecting the fact that the coefficient is statistically equals to 1. Therefore, we are accepting the alternative hypothesis that the coefficient is statistically different from 1, which means it is significant, right? So since it is significant, we need now to check its mathematical value. Had it been it was insignificant, that is equals to 1, then we don't even need to check the mathematical value. We just conclude that the systematic risk of the stock is equal to the systematic risk of the market. But since we have found that it is significant, it is different from 1, therefore we need to check its mathematical value. Is it greater than 1 or less than 1? If it is greater than 1, then the stock is riskier than the market. If it is less than 1, then the market is riskier than the stock. So since we have found that this value is significant, and then now mathematically 1.53 is greater than 1, therefore this stock is riskier than the market. Do you understand that? So these things are very easy to interpret. It's not too difficult. So that is how we should interpret our coefficients. I'm not going to write it down. If you watch the video, you can listen to what I've said and you understand. So to interpret the alpha, we are using the hypothesis equals to 0, different from 0, right? And if it is equals to 0, that is, it is insignificant, it means the stock is fairly priced. There is no undervaluation, there is no overvaluation, there is no mispriced. It is not mispriced, it is fairly priced. But if it is significant, which means it is statistically different from zero, it means the stock is mispriced. There is either undervaluation or overvaluation. Now we need to check if it is undervaluation or overvaluation. We should check the mathematical value of the alpha. Is it positive or negative? If this alpha is positive, it means the stock is undervalued. Correct? If this alpha is negative, it means the stock is overvalued. Correct? We are done with alpha. Now for beta, we should use the hypothesis equals to 1, different from 1. And I've showed you how to do it on e-views. Now, if it is statistically equals to 1, which means it is insignificant, then we don't even need to check the mathematical value of the beta. We just conclude that systematic risk of stock is equals to systematic risk of market. But if it is significant, that is statistically different from 1, then we need to go one step further and check its mathematical value. Now, is it less than 1 or greater than 1? If it is less than 1, then it means stock is less riskier than market. But if it is greater than 1, it means stock is riskier than market. Understood? So you discover that this CAPM model, we are checking two things. We are checking first if the market is efficient, because if the market is efficient, then alpha should be 0, statistically equal to 0. There should be no undervaluation or overvaluation. It should be fairly priced. But if alpha is significant, then it means the market is not efficient, right? There is undervaluation or overvaluation. We can check, is it negative or positive? So that's the first thing we are checking with CAPM. It tells us if the market is efficient or not. Second thing we are checking is the beta. We are trying to check if the stock is riskier than the market or if the market is riskier than the stock. Okay, I think that is fine. In order to make sure you have understood, I'm going to give you an assignment. And let me check the assignment. Where have I stored the assignment? Let's look at it together before I give you. Actually, I'll give you 10 days for this assignment. So today is 16th, so deadline should be 26 midnight, Saturday. You'll have enough time. So in this assignment, I'll give you these 4 guys. I'll give you S&P 500, which is a market index, right? I'll give you this stock, Citigroup closing prices. I'll also give you this stock, and I'll also give you this stock, so 3 stocks. What we have done for just 1 stock, but you can do it for many stocks. And then I will give you, where is T-bills? Consider the risk-free rate to be 1.15% for each period. Treasury bills, risk-free rate, right? And then this is the CAPM model you should estimate. Of course, you know this is excess return of stock. Return of stock, expected return of stock minus risk-free rate. This is Jensen's alpha, right? This is excess return of the market, expected return of market minus risk-free rate. This is beta, which is the systematic risk of the stock. And we have stochastic error term. So what you should do is answer these questions. And I can remember, I'm going to change some things here. I can remember question 5, they are asking you here, are your results in accordance with efficient market hypothesis? So you should tell me if the market is efficient or not. And to know if the market is efficient, you should check alpha. Is alpha significant or not? If it is significant, market is not efficient. If it is not significant, market is efficient. And if it is significant, you should tell me if it is undervalued or overvalued, right? If it is significant and positive, it means the stock is undervalued. If it is significant and negative, it means stock is overvalued. And remember, when checking alpha, we are using the null hypothesis equal to 0, not equal to 0 for that hypothesis. But you are checking beta, we are using the hypothesis equals to 1, not equals to 1, and I'll show you how to do it on e-views with what tests. Yes.
For the future bills, it's 1.15%. Is it annually or we should remove the annual?
It is T-bills. You should remove the annualization. Just do it like the same thing we have done here. So I think it's a very easy assignment. Let me see. Estimate 3 regression equations. Excess market return versus excess return for each of the stocks. So you do it for what we have done, do it for each stock. So 3 different regressions because there are 3 stocks. Write down the estimated equation. Interpret the slope and constants. So you know that the slope is telling you about the systematic risks of the stock, and you should check the significance. Beta equal 1, beta different from 1. The constant is telling you Jensen's alpha, if there is underpriced or overpriced, is market efficient or not. I will delete this. Do not use e-views. You should use e-views. Here they say hints. Do you need any hints? Okay, yeah. What is Jensen's alpha for each of the models? So you should check the Jensen's alpha. What are the each alpha values? What do they tell you? So you should check. You should be able to interpret the alpha. If it is significant, it means market is not efficient. It means the stock is mispriced. If it is insignificant, it means market is efficient, the stock is fairly priced. And if it is significant, which means market is not efficient and stock is mispriced, you should be able to tell me if it is underpriced or overpriced. That is undervalued or overvalued. Yes. So I should remove these hints. You don't need any hints. I've given you all the hints. If you need any hint, go and watch the video. Make comments of the overall quality of the models. Okay, I'll tell you something about that. I should remove the hints. I want to make your life difficult, so you don't need hints. Are your results in accordance with efficient market hypothesis? I've told you how to check that. You don't need any hints. So just 5 questions you should answer. Okay, so I will send the assignment in the group. I think that is it about CAPM, but I will show you something. By the way, we still have time. We still have like 20 minutes.
We didn't take a break, so this continues because
You don't need a break.
you don't need a break, we are humans.
No.
And I have a tutorial after 30 minutes. I need to eat.
I've been teaching since 8:30. Nobody gave me a break. So why should I give you a break?
And the drinks studying and invigilate things at 10:30 without any break. And I have after 30 minutes also class. So
But there's something interesting I want to show you. So what should I do? I should not show you?
okay, show us.
Guys, let me show you something. Delete the equation, yes. Let's do a multiple regression. What can I do? Have you done multiple regression?
No, after midterm.
After midterm?
Yeah.
Oh, I see. I see. But I'm still going to show you. I will not show you multiple regression. Actually, what I wanted to show you for the case of multiple regression. I will show you for the case of simple regression. It's still, I've showed you before, but I want to be sure you know it. So it will take me just 10 minutes to run expected return. What should I write? Of for constant expected return SP 500. Okay, guys, this is regression results. We have seen how to interpret coefficients. This is not for the case of CAPM, like normal regression, right? Forget about CAPM. So for normal regression, we have seen how to interpret coefficients. We have seen how to check statistical significance, t-statistic probability value. But I'm interested in these guys down here. There are some very important guys here. This arrow squared, this adjusted arrow squared, this F statistic, these three guys are very important. I want to show you how to interpret these guys. It would have been easy for multiple regression, but for simple regression, it will not be too long. I'll just try my best. Rho squared. By the way, I showed you this. This Rho squared, this value, it shows the explanatory power of the model, right? And it should be greater than 50%. If it is higher than 50%, it means the model has a decent explanatory power. If it is like 80-90%, we can say the model has a very high explanatory power. But if it is less than 50%, like you see here, 28%, it means the explanatory power of the model is low. Actually, what is our model? Our model is y equals alpha plus beta x plus u. So if the explanatory power of the model is high, it simply tells you that this x, the variation, that is the variation in y, dependent variable, can be explained well by the variation in the independent variable. So it simply tells you that this independent variable explains this dependent variable to a high degree. You understand? So it's telling us the explanatory power of the model. It's actually called a coefficient of determination. Now, this adjusted Rho squared is actually Rho squared, but it is adjusted. Why is it adjusted? If you notice, in this case, these two figures are the same because it's simple regression. We have just one variable. But for multiple regression, let's say we have an extra variable like, let's say, plus CZ plus U. So let's say we have two independent variables, X and Y. What you will notice is that the more you add independent variables to your model, your Rho squared will go up. Rho squared will increase. But if your Rho squared is increasing and you have a high explanatory power, it looks like your model is good. But the question is, these variables you're adding to the model, are they useful or useless? Whether you add useful variables or useless variables, your Rho squared will go up. Just know that. Whenever you add more variables to your model, even if the variables are useless or they are useful, your Rho squared will go up. Of course, we want a high Rho squared because we want our model to have a high explanatory power. Is this Rho squared high because we have added many variables, or is it high because the model actually explains what is happening in the dependent variable? So we need to use the adjusted Rho squared. This adjusted Rho squared is like a punishment. It punishes you for adding more variables to the model, right? So that's the reason why you discover that the adjusted Rho squared will never be higher than the Rho squared. It will either be the same or less than. Because when you add one more variable to the model, the Rho squared goes up, but the adjusted Rho squared punishes you for adding this extra variable. Now, if this extra variable is very useful, then this punishment will be small. So the Rho squared and the adjusted Rho squared will be close to each other. But if this variable is very useless, the punishment will be big. So the adjusted Rho squared will be very far from the Rho squared, right? That's why you should always take Rho squared minus adjusted Rho squared, and you should get the answer. If the value is too big, then it means most of your variables are useless. But if the Rho squared and the adjusted Rho squared are close to each other, it means most of your variables are useful in explaining the variation in the dependent variable. So adjusted Rho squared and Rho squared are used to check the quality of the model, because I can remember here in this assignment, I asked, where is it? Did I delete it? That you should make comments on the overall quality of the model. So you should check first of all, check the Rho squared. Is the Rho squared high? If it is high, it's good. But now you should also check the adjusted Rho squared. Is it the same or close to the Rho squared? If it is close to the Rho squared, and then the Rho squared is high, then it means the model is good. But even if the Rho squared is high, if the adjusted Rho squared is like far from the Rho squared, it means Your R squared is just high because you have many variables. The variables are useless, so you should check that. And then one other last thing you should check is the F statistic. F statistic. We have been checking T statistic throughout. Now we should check F statistic. Actually, T statistic is used to check statistical significance of your individual variables. For instance, we want to check if this coefficient is significant, we want to check if. So, like these things are important for multiple regression. Like you see, this is a variable and this is a variable. So if we want to check if X is statistically significant, we use T statistic, T test. If we want to check if Z is significant, we use T statistic, T test. So the T test is used to check the statistical significance of the variables individually, one after the other. But now with the F test, we are going to check the statistical significance of all the variables together, jointly. So what you notice is that, well, maybe some of the variables might be individually insignificant, but if we check for all of them together, it might be significant, right? So the F, so let's assume we have this. So for F test, let me see. First of all, let's do T test. T test, I've showed you before. What is the null hypothesis for T test? Itching to go. I'm finishing, I'm rounding up. What's the null hypothesis for T test? The coefficient is equals to 0. Alternative hypothesis, the coefficient is different from 0, right? So we check each of the coefficients individually. So to check if X is significant, why is not highlighting? We use this T test. To check if Z is significant, we use T test. So we check if each of them is significant, one after the other. But for F test, and by the way, for T test, we use T statistic. For F test, what's the null hypothesis? So of course, we have here, by the way, this can be like beta 1, and this is beta 2. So we have here beta 1 equal 0 and beta 2 equal 0. That's the null hypothesis. And what's the alternative hypothesis? Beta 1 is different from 0, or beta 2 is different from 0. People always get confused here. Here is and, here is or. You have to be careful. So the null hypothesis is telling you that each of the coefficients is equal to 0. This one is equal to 0, and that one is equal to 0. But the alternative hypothesis is telling you that at least one of them is different from 0. This one is different from 0, or that one is different from 0, right? So you have to be careful about that. Now we use F statistic for the F test. Check the probability value. Probability is 0, right? If probability is 0, it means it is less than 5%. So we are going to reject the null hypothesis and we accept the alternative hypothesis. This null hypothesis tells us that the coefficients are jointly insignificant. For T test, it's for individual coefficients. Each coefficient is insignificant for null hypothesis. For alternative, each coefficient is significant. But for F test, it's telling you that all the coefficients combined are jointly insignificant. But for alternative hypothesis, it's telling you that at least one of them is significant. So if you reject the null and you accept the alternative, then you conclude that the model is a good model. The model fits the data well because the coefficients are jointly significant. Okay, let me let you go since everybody wants to go. Please watch the video if you can. Do the assignment. Wait file. These things can get confusing at times, but
test, so there is no measurement. After F test, we check the probability.
Yes, F test, we are checking just probability. And these are the hypotheses. Hypothesis is that each of the coefficients is equal to 0. So we are using and. Therefore, alternative hypothesis, we are using or. At least one of them is different from 0. So this is different from 0 or this is different from 0. If you cannot reject this null, it means jointly all the coefficients are insignificant. So your model is a bad model. But if you can reject this null, it means jointly your coefficients are significant. So it's a good model because the model fits the data well. So to check the quality of the model, you should check a rho squared, adjusted a rho squared, and F statistic. Okay. I think that is fine. See you guys. By the way, good luck in your midterm exams because we have no class again until after midterm, right? So see you in December. Bye bye.